let's talk about representation. So when we represent a discrete time signal, there's a bunch of ways we can talk about it. We can talk about notational ways. And as an example, we might say x of n or h of n. So in these examples, we're using square brackets, right? It looks almost like our x of t in continuous time, but we use square brackets just to make it totally clear we're talking about a discrete time signal, and also our indexing variable, our independent variable, our t variable becomes an integer. And so by default, we change it from t, which makes us think of continuous time, into n. So as an example, we might say, what is the sum over all possible indexes of h of n? Anyone, what does h of t represent back in signals and systems?
Is that the transfer function?
Almost. The transfer function was an h of s. H of t certainly talked about the system, but what did we call it? What was our h of t referring to?
That be the impulse response?
The impulse response, that's it. So this is also the impulse response in the discrete domain. Same thing. Let's see. And just as in the continuous time, if the integral of, in continuous time, if the integral of h of t over all time was less than infinity, that meant it was stable. It was a stable system. It wouldn't blow up. If this is less than infinity, it's also a stable system. So you can see how integrals just get replaced by summations. In some ways, this way, DSP is actually easier than continuous time. The next is graphical. And instead of a plot, it's a stem plot. So as an example, here's an example of a stem plot. In MATLAB, you'd create this plot. Let's say this is 1, 2, and 3. You'd create this plot by filling in your data vector. Of course, there's no of n signal. So instead, in MATLAB, you've got your prompt. You'd say x equals, and here's your data, 1, 0, 2, 0, 3, 0, 2, 0, 1. And then you'd need to create an index vector. And so for this one, it would be -4, -3. Man, that's going to take a long time. Instead of saying it this way, let's just say n equals -4 colon +4. You can put a semicolon after it so it doesn't echo it to the screen. And then we just found a faster way to do that. And then to stem plot it, you'd use the stem command. And it's got the same notation as the plot command. You use the horizontal data first, and then the vertical data. And that will give you what you want. What is, in this particular sequence, what is x of 1.2? Hey,
Just,
yeah.
I was going to say it doesn't exist, sir.
Yeah, does not exist. Does not exist. The question itself does not make sense. if you line people up in order from shortest to tallest, what's the name of the person who's in the 1.2 position? It fundamentally does not make sense. It's not 0, which is an error I see a lot of people make. The next is, so far, everything we did with DSP, we could just as well have done in continuous time. We've got notational representations for continuous time. We've got stem representations for continuous time. Sequence representations is one that does not make sense in continuous time. Since we only have a finite number of, since they're separated by unit indices, we could write our sequence directly, just as we did in MATLAB, 1, 0, 2, 0, 3, 0, 2, 0, 1. And if we're doing it by hand, rather than write the index, you can use an arrow underneath to specify where your 0 point is. And think about this for a moment, why you can't do this in continuous time. There's an infinite number of potential points between time equals -4 and +4, whereas in discrete time, there's only 9. So that lets us write things as a sequence. And the fact that we can write a discrete time sequence, a discrete time signal as a sequence, is why you're learning about it right now. Everything in digital signal processing in general is, with few exceptions, is trickier than in continuous time. But discrete time signals are a thing. The reason why the course exists is because you can represent them as a sequence, which means you can stick them into a computer, which means you can have the computer chug out repeated numerical operations rather than you having to deal with algebra. And that's the purpose of the course.